Today we're going to look at how we find horizontal and slant asymptotes. Vertical asymptotes are easier to find. Horizontal and slant asymptotes take a little bit more work to find. So what you should do is first divide the polynomial. So you're going to be dealing with a rational function. It'll look like something over something else. And when you divide those, the non-remainder part is the horizontal or slant asymptote. So that means special things when you know something about the degree of the numerator and denominator. So if the denominator is bigger, you're going to get something like, you're going to be looking at something like, say, x squared minus 20, and then in the numerator you have a smaller degree. So if the denominator is bigger, then when you divide these, you're not going to get anything. You'll just get out this is the remainder, and there's no integer part. So the denominator, if the denominator is bigger, then the horizontal asymptote will be y equals 0. Every time, because if the denominator is bigger, then the numerator is smaller, and there's nothing to divide into. Not enough to divide into. What if they're equal? Then that would look like something like x squared over x squared minus 20. And if this happens, then the shortcut to doing this division is just divide the coefficients of those leading terms. So here we have 1 divided by 1, so it would be a horizontal asymptote of y equals 1 in this case, but the short way of writing it is divide the coefficients. And that's only if the degrees are equal. They could be x to the third and x to the third, but they have to be the same degree. And if the numerator has a higher degree, something like x cubed over x squared minus 20, then you're going to actually have to divide. And that'll be a longer process, and that's when you'll get a slant asymptote. So you'll only get a slant asymptote if you end up getting a higher degree in the numerator. Lower degrees in the numerator mean it's y equals 0, and the same degree means that it's y equals a constant. So let's find